Hello, everybody. Today I want to talk about buoys, so let's get with it. Uh, we want to let this team follow the design principles that are taught in the capstone project in your senior year. And this is a great way to get introduced to it. The first thing we want to do is we want to get a good scope of work of what we're going to do. And we've talked about it, but now you guys need to commit this into a statement of work. So one way to start this statement of work is we're going to put up here what we want to build. We want to build a buoy, right? And let's talk about, or let's define that buoy, and let's put some things we want it to do. Well, one is we want it to be free floating. And by that we mean we want to be able to turn it loose here in the Gulf of Mexico, and wherever it goes we want to be able to collect data and be able to communicate that with it. So all right, so the next thing we want to do is we want to describe how long we want it to last. So the lifetime is we want it to outlast our satellite. So let's just stick a number up here. Let's say 3 years. And then because it's going to go all over the world and that is unpredictable, we want to use satellites, especially our Cape satellites, to be able to communicate with it. So the COM will be satellites, and here are the satellites we want it to work with. We want it to work with Cape 2, and that's the primary satellite. But we also want to be able to use what's up there, and one of the things that's up there is the International Space Station. The other is something called PCSat. And another satellite to come is FunCube. All right, now let's talk about what it's going to do. And one of the things we want it to do is we want it to measure water or wave height. We want it to do wind speed. We want it to do wind direction. We want it to do its location. We want it to do the temperatures. Both the air and the water. And we want it to do the salinity. All right. And how is this going to get its energy source? And we can use batteries. And B is photovoltaics. Photovoltaics being the primary one. The form factor, my suggestion is a 4-inch cylindrical probably a 4-inch PVC pipe. Let's say we want it to be operational, survival at a sea state of say 30 feet. And the temperature range we'd like it to work over is say -10 to +40 degrees C. All right. So now we have sort of described what we're going to do, right? Now, the next step is after you do this, and you need to make this in a verbose statement, post it on .project. The next thing in the design process is called a level 0 drawing. All right, the level 0 drawing is where you essentially have an empty box, and on one side of the box we put the inputs, and on the others we put the outputs. Well, the inputs are the energy. Something has got to supply this thing with energy. And then the sensor data, the wave, the wave height and direction, the wind speed, the location, the GPS location, the temperatures, both the air and the water, and the salinity. Right, and the output is the comms to the satellite. And this is a level 0 drawing. Now, what I'd like you guys to do before the next meeting is to formalize this in probably a Visio document or some sort of nice document that we can archive and refer back to, and paste it on .project. And I want to remind you of the drawing of a guy sitting in front of of an outhouse, you know, and he says, my job is not finished until the paperwork's done. And this is true in this project, and I think we ought to insist that you guys actually not work very informally, is actually start to do formal presentations. So by next meeting, which I intend to be there, I'd like somebody to get over here and actually present their drawings in a PowerPoint presentation. And I also would like you guys to assign to each other which of these systems or subsystems you'll work on. Remember, comms, energy, and all of these inputs here. And a good source for some of this stuff is SparkFun. There's lots of these sensors on SparkFun. So until next time, so long.